So the water comes in and it's going to fill, it's going to fill up and blow out all the air that's in this. And there's an air release over here, but it will fill up and it will push literally all the air out of here, so that when it completely pressurizes, there is zero air in this pot. And it's all water. Now that water slowly, as it seeps down into the grit, doesn't fill this pot up, but it penetrates the grit. It fills in the little cracks. It saturates the grit to about there, essentially.
You said about like pouring water on beach sand.
Pouring water in a cup of beach sand, and if we had a clear cup full of beach sand and you pour water on that beach sand, the water would stay on the top and it would slowly saturate the grit. But this acts as a pressure plate. This water actually acts as a hydraulic plate that pushes this grit down, and as it pushes the grit down, it's slowly saturating it. So you have some damp grit that's coming out. Actually, what you have is grit that's damp coming out and being picked off. That's how that works. So once this is pressurized and this is open, and the grit could come out into the blast stream. Sorry. It will just sit there. This is pressurized and it will just sit there. Nothing will happen. And this is fully pressurized to the pressure you want it. Mm-hmm. Up until I decide to put, once it's completely pressurized, I decide to put an extra 3 drops of water in the top of this. It's fully pressurized. This is now open to the blast stream. If I put 3 drops of water into this, it has to get rid of something, or otherwise there will be no way that water could enter that pot. It's simply impossible. It's completely under pressure, and I could not force anything in there unless it had a way to escape or displacement. Now it will displace. If I put 3 drops in here, it will displace 3 bits of grit out of there. That's a theory. Obviously it works a little different than that, but that's technically what's going on. So for every amount of water I put in the top, I have that amount of grit coming out of the bottom. It has to. It has no place to go. If nothing was coming out of here, nothing would go in there. It's impossible. Water can't be compressed. So once it's compressed to the point of the set pressure, nothing will happen. The pump will pump.
All right. Now talk about the theory of the media now having more mass.
Man, if I could show you, I can show you. I can take dry grit and throw it, and then take damp grit that's actually in the truck right now. I can grab that damp grit and throw it, and they can actually see the difference if you want to do that out there.
Sure. Let me start over.
Okay. Now we're going to add water to the top of the pot.
It's displacing all of the air out.
It sure is. See the bubbles?
Mm-hmm.
It's slowly, but technically the water sits on top, acts as a pressure plate, gets rid of all the air, but you notice this is damp and this isn't down here.
Right.
It's really damp right there, but by the time you get down here, there's hardly anything there. This grit is wet because there's water being pushed down and it's slowly saturating it. And down there at the 90, I wish all these hoses weren't there, that grit is being pushed, right? And it's being pushed through that hose right up through here, pushed up, up into this pipe right here.
And that's the
So
dead man
this-
switch right here.
That's right. So this grit looks just like that, and it's stopping right there because that dead man is stopping that grit. It's under pressure. That there's 120 psi or 80 psi or whatever you have that thing pressured at. That's what's pushing this up, but it can't go any further because it's stopped at the dead man. When you hit the dead man, it opens up this valve. It also opens up this check valve, allows the air to come down here, and it's shoving. This is now open, so it now allows this grit to be pushed up into this airstream, and it slowly is picked up. And that's all it's doing. It's picking it up like that.
So, and then this is just a typical 2-to-1 Merkur pump
That's right.
that's plugged into a supply of water or a tank, and this is what's pressurizing the vessel with water. And
That's
you're
right.
only putting in a small, tiny amount of water as this is dispersing
correct.
the media because it's displacement theory
That's right. Once
with
the
liquid
pot is,
rather than air.
That's right. Once the pot is pressurized, now we're going to put in a lot of water right up to. We're going to fill the top.
So you're not putting any air in the pot at all.
No, zero, no air.
That's the
whatsoever.
difference.
That's why we can be carbed, we can be safe, we can be all of those different byproducts. Also, that little tiny grit, that 80 grit, you heard it thump. Now we are able to take that, we're able to penetrate, as opposed to a heavy grit, right? Think of marbles and think of, grit, right? Or rocks and grit. And the marbles hit and they're bigger spaced apart. But 80 grit hitting at the same rate with that much mass, you now have just as much penetration in your steel, but you have more peaks and valleys as
Per square
opposed to,
inch.
so you have more of an adhesion for paint to adhere to.
Excellent. Thank you. Go ahead.
And we throw it, and it just kind of goes, it just disperses.
Right.
We take that exact same grit. And it looks just like that coming out. So you can see there's no water running off, right? That's what you have. That's exactly what's coming out. Now watch the difference. As opposed to that same mass.
I missed that. Do it one more time.
Do you feel? I mean, you can hear.
Yeah, you can hear the difference.
See, that's exactly what's happening. That's it. That's the whole theory. Let me show the. Here's the same amount of grit.
You see it? Okay, just a little handful. And you can hear it.
80 grit. As opposed to nothing.